Okay, so number two is going to be a little bit more challenging. Okay, and there's going to be a couple of new concepts. You should open up your postulates and theorems document. Okay, because there's a couple of things on there that I'm going to use in this case. Okay, so I'm going to start marking my givens, but ultimately I want to prove SW is common to TW. Okay, look at those two sides, SW and TW. That's what I want to prove. Okay, so I want to somehow get those two thin triangles, SLW or TLW, okay, or RSW and RTW congruent to each other, and then by corresponding parts, those two sides. Okay, so that's going to be the goal. So let's look what we have for the givens. All right, so I've got RS congruent to SL, perpendicular. That makes that a right angle. Okay, and RT congruent to LT. That makes that a right angle. Now look at where I'm stopping that. Okay, that's within those two smaller triangles. Okay, it doesn't go all the way to TW or SW. Those are the right angles right there. Okay, and we have RS congruent to RT. Okay, and then of course by reflexive, I've got RL congruent to itself. So I can prove those two triangles congruent by hypotenuse leg, no problem. Okay, now look at this other given over here, RLW. It came out a little bit weird when I converted this to a PDF file, but it should look like this, RLW, and that should be a segment RLW. And what that tells me is that RLW, look at that right down the middle there, RLW is a straight line. Those lie in line with each other. They're what we call collinear. Okay, so that's just telling you RLW is a straight line segment. That means the angle there at L, okay, that's kind of a straight angle there. Okay, it doesn't kind of go off on a little tiny angle telling you it's a straight line. So if you see something like that in a proof, it's probably important that that be a straight line. And that's what's going to happen here. Okay, because now what I'm going to do is I'm going to call this angle 1 and angle 2 in my proof. I'm going to call this angle 3 and angle 4 in my proof. Okay, I'm going to call this 5 and 6. Okay, since RLW is a straight line, okay, that makes 3 and 5 and 4 and 6 linear pairs. Okay, linear pairs by definition of linear pair. Okay, that makes them supplementary. If 3 and 4 are congruent, and 5 and 6 are supplementary to those, then 5 and 6 must be congruent. Okay, so that's the idea that we're going to put into this proof that's going to be a little bit different. Okay, and then we've also got SL and TL for CP/CTC, but that's getting a little ahead of ourselves. So that's the new idea that you should look at for postulates and theorems. We're looking at these two. We're looking at two angles form a linear pair, they're supplementary. And if two angles are supplements of the same angle, then they're congruent. All right, so let's go here. So 1, okay, RT, RS is congruent to SL. RS is, perpendicular to SL. And we're going to say RT is perpendicular to LT. Okay. Good. All right. Now, since I'm going to use hypotenuse leg, okay, I just need to say that angles 1 and 2 are right angles. Okay. That is 2. That's by definition of perpendicular. Okay, they're right angles, which is going to make triangle RSL and triangle RTL right triangles. Okay, that is 3. That's by definition of right triangle. Okay, so they're right triangles. So now I'm free to use hypotenuse leg. So 4, my other given is RS congruent to RT. RS congruent to RT. 4 given. And then I can also say 5 RL congruent to RL. 5, that's reflexive. Okay, so those two triangles now, 6, those two triangles, RSL is congruent to triangle RTL. Okay, and I showed that using 6 hypotenuse leg congruent to hypotenuse leg. Okay, so now that I've got the two triangles congruent to each other, I can say angle 3 is congruent to angle 4. Okay, and that is by CPCTC. Okay, 8. Statement 8 now is where I'm going to use that different looking given, that RLW. RLW is a straight line. Okay, that's given. Okay, because now I can say that 3 and 5, 9, angle 3 and angle 5 are a linear pair. Okay, and that's by definition of linear pair. Okay, but I'm also going to say angle 4 and angle 6. Angle 4 and angle 6 are a linear pair. Okay, that is 9. That's by definition of linear pair. Okay, that's going to mean, okay, again, looking back at this postulate and theorem here, if theorem 7, if two angles form a linear pair, then they're supplementary. So I'm going to say 10, I'm going to say angle 3 is supplementary to angle 5, and I'm going to say angle 4 is supplementary to angle 6. Okay, linear pairs of angles are supplementary. Okay, linear pairs of angles are supplementary. Okay, so angle 3 is supplementary to angle 5, and 4 is supplementary to angle 6. Okay, now look, in number 7, we said angles 3 and 4 were congruent to each other. Okay, well, that's going to mean angle 5 is congruent to angle 6 then. Angle 5 is congruent to angle 6, and the reason for that, again, looking at the postulates and theorems, okay, so now if you look at theorem 6, if two angles are congruent, their supplements are congruent. Okay, so that's what we have here. We've got angles 3 and 4 are congruent, okay, and they have supplements, okay, 5 and 6. So that means the supplements of congruent angles are congruent. Okay, I got to number this one, 10, okay, and now 11, supplements of congruent angles are congruent. Okay, so that would be the reason for number 11. That makes angle 5 congruent to angle 6. Okay. I can also look back at that original set of triangles, the hypotenuse leg triangles. I can say SL is congruent to TL. SL is congruent to TL. Again, that is by CPCTC from those triangles. Okay, so 12 CPCTC. Okay, and now I've got, I've also got LW congruent to LW. Okay, right here. Okay, so LW is congruent to LW. Okay, that's by reflexive. Okay, and finally, now I can say that those two triangles, okay, 14, triangle, I can't even see the diagram anymore, SLW and TLW. SLW is congruent to TLW. And how did I prove that? I used side angle side. Okay, so I used side angle side, congruent to side angle side. Okay, and that's going to mean now 15, I can finally say SW is congruent to TW. Okay, and the reason being CPCTC. Okay, so again, there's a lot involved here. Okay, we had to prove those two triangles at the top congruent so that we could use the parts of that triangle to get the parts in the second set of triangles and then say CPCTC for those two parts. Okay, so the trick to these kinds of questions is going to be which triangles can I prove and which parts of those triangles can I use to prove the ultimate statement. Okay, the ultimate statement I'm trying to prove. Okay, so that's that. There is another document for homework. Try those. Okay, I believe one of those, the third one, is going to use this whole supplementary to congruent angles idea. That's why I wanted to introduce it here. Okay, so just be aware of that. Okay, those 8, 9, 10, 11, and 8, 9, 10, and 11, okay, are going to be used in the homework. Okay, so good luck, and we'll see you next time.